Glad to see everyone this morning. Hope everyone's fresh and excited for a really exciting presentation. As you know, HP is one of our best partners and has really made this possible. They're the platinum sponsor for MoabCon. They're very involved in both the HPC and cloud computing markets. And as I've talked with many of you, I know that many of you work with HP as well. So we're very excited to have on the stage with us here two of our HP representatives who are going to talk to us in a morning fireside chat fashion with our CEO, Rob Clyde. We have Jerome Labatt and Mark Hamilton from HP, and we'll introduce them in just a moment. But we're excited to work with HP. They've done a lot of exciting things over the years in HPC. Even yesterday, they made some pretty big announcements in their cloud computing front, so we're excited to hear more about that. And with that, I'll turn the time over to Rob Clyde.
Thanks, Chad. It's a pleasure to be here this morning. I lost my voice, so you'll have to bear with me a little bit. Fortunately, our esteemed guests are going to be doing most of the talking. So first of all, as Chad said, we're just thrilled to have our partner HP here with us this morning. I had the opportunity to talk to Jerome yesterday, and he walked me through. And fortunately, I had a lot of time. You'll have a little less, but I'm sure they'll be happy to answer more questions. But he walked me through the significance of the announcement that HP did yesterday. And so I would like to hear a little bit more about that. But first of all, maybe we could have Mark Hamilton and Jerome Labatt. If you could each introduce yourselves, and then we'll start with some questions.
Sure, Mark Hamilton from HP, and I run the high-performance computing team for the Americas. So I've been in the HPC space and the software space and the computing space for quite a long time, and very happy to be here today with our customers and our partners, Adaptive.
Sure, and Jerome Labatt, so I'm responsible for engineering at HP when it comes to cloud automation solutions. And I've been in that space for quite a long time too, automating engineering environments, production environments, IT environments, and things like that.
Jerome, you came from Intuit prior to this.
That is correct, where we had a great journey in transforming from what I would call a traditional environment, CD-based, desktop-based applications to a pure SaaS-based environment and model. So transforming the IT department, transforming the IT infrastructure, transforming the applications, moving to SaaS.
So, speaking of cloud, could you tell us a little bit about the announcement you did yesterday?
Sure. So when you look at cloud, there's a lot of notion and ideas around cloud, and so one of the key thought process that went through the announcement and the work that we had is to really kind of normalize and think about what is cloud. And so the first point of view that we have is cloud is really about a delivery model. It's going to be, it's an evolution of where we are in the industry. If you look at what's happening with the application, with the tectonic shift that's happening right now in terms of social, mobile, the ability to collect data and look at what you need in terms of insight on how your applications are behaving and working. It's not one way to deploy application anymore. You're going to have choices, you're going to need choices. And so what we think about, when we think about cloud, when you look at cloud, we look at a hybrid delivery model. You can run your application on-premise in your data center, in your existing traditional environment. You can run your application in what we would call a cloud or private cloud environment, where you have compute capacity that's going to behave a cloud-like environment. So it's going to be scalable, flexible, it's going to respond very quickly, and then you're going to be able to run that on a public cloud environment. So your application is going to run in all those different environments, and that's really what we mean by hybrid delivery. So from an HP perspective, we believe that the world going forward is you're going to have to manage application deployment, operate applications, workloads across those different delivery models. And so our challenge is how do we go there? How do we put together an architecture that is going to resonate and allow you to do this across the board over time? So that was a lot of the context behind HPC being one of the workflows we want to be able to address.
Great. So Mark, you're a longtime HPC guy. From your perspective, is the cloud applicable to high-performance computing? And if so, how?
Well, absolutely. I talk to a lot of HPC customers, and they say, it's about definition. They say, well, we've been running a cloud forever, right? And if you think about it, HPC cluster where you're doing job scheduling with Moab, and might have been doing that for many, many years, certainly shares some of the attributes of a cloud. That you have shared use hardware, you may have you have a scheduling system, you have access to it. It certainly doesn't have all of the attributes of a cloud. So you would think that HPC customers would be one of the very early adopters of cloud computing. On the flip side, there's certainly challenges, at least when you speak about a purely public cloud. Some of those have to do with the amounts of data that you need to move. If you need to move petabytes or hundreds of terabytes of data across the cloud, that can be an impediment. But I think that certainly from the hardware perspective, what cloud and HPC are really forcing HP to do is change the way we think about servers, because customers in either cloud or an HPC space aren't just buying 1 or 2 or 10 or 20 servers at a time. They're buying hundreds and thousands of servers at a time. So now you have to think about not just building and designing a server sort of standalone. You need to think about designing a server with the networking, with the storage, with all of the software infrastructure, the power and the cooling infrastructure, the management infrastructure, and think about designing that as a unit. So it really is driving the change, certainly not only things that we're doing on the cloud software side, but a lot of implications on the hardware side as well.
Awesome. So, Jerome, we've heard a little bit about, cloud and HPC from Mark's side. From your perspective, how does cloud compare, how does it compare to traditional enterprise workloads in the enterprise side when you're looking at cloud there?
Sure. I mean, so when you look at the enterprise and you look at web application or some traditional ERP system, for example, the construct of having the specialized hardware with specialized workload, the massive scale you're describing is kind of hard to fathom or understand in the traditional IT. However, if you look at the evolution of where those businesses are going, there's a need for insight. There's a need to be able to look at data, massive amount of data. And even in my past life, the experience was like, how can I bring this insight, this massive crunching of data, and start to look at it in a more efficient way? And this is where the HPC experience and the environment and stuff that Mark described is actually coming to bear. So if you look at an Hadoop cluster, for example, and the ability to run a Hadoop cluster efficiently, looks very familiar from an HPC lens. And so what you're going to see is a convergence over time, I think, on specific workloads first. So you can introduce this in your data center. You can introduce the new thinking and the cloud behavior in the data center and learn from there and start merging over time over it.
Great. So what levels of interest are you seeing among customers, among cloud customers that have interest in HPC or among HPC that have interest in the cloud? And what do you think is driving that?
Well, in a very naive sense, I think there's many HPC customers that love cloud because they think it's free. But certainly certainly the ability to have, I think, cloud bursting and to not have to provision for your peak workloads and being able to do cloud bursting, there's certainly a huge amount of interest there. It's not a lack of interest, right? It's, I think, the challenges, and it's been the limitations of the existing cloud environments in being very special purpose, right? You could build a private cloud, you could go use a public cloud, you could have traditional infrastructure, but you could have a managed cloud, but there was no way to bridge across those environments. And so that's one of the things that HP really announced yesterday, is really our first what we call converged infrastructure cloud that does let you bridge across those 4 environments: traditional, private cloud, managed cloud, and in true public cloud. I think that Jerome talked a little bit about sort of the merging of traditional HPC and big data. And in the HPC space, that's been a big topic of discussion. And if you think about it, what HPC customers have done is they've typically had some parallel file systems where they stored a lot of data. Think of an automotive company that's doing a bunch of CFD analysis for crash data, and they crash their cars in the design stage. Why wouldn't you go and take that data and then take all those crash models, move them off of your Lustre file system, put it out on a distributed Hadoop file system, and then every time you get crash sensor data back through OnStar, you could feed that back into your crash model. Again, I don't think anyone's doing that today, but that's a great idea and a great example of where you would merge HPC and big data in a real life example.
Great. Have you seen any real examples where this kind of thing has been done yet?
I mean, from some of the web properties that you've seen on some of the customers that are moving to SaaS-based application, you start to see a lot of that work, because one of the key elements of a SaaS property or the web property is to understand what is the experience of the customer, and you need to really understand what's happening in your application, what's happening in the infrastructure, if your quality of service is met, and that requires a lot of data, a lot of monitoring content coming in. And a more traditional way to look at it would be just by regular instrumentation. Going forward, you need to add a lot more knowledge content. You need to look at your log and then crunch all that data. And so the Hadoop cluster will be the first one that will come out of mind. But I think we'll see a lot more of that.
That's great. So along these lines, what does HP offer for this kind of thing in order to do HPC in the cloud? What do you have?
I'll let the HPC expert on the...
So again, certainly we start off by providing all of the base infrastructure, right? The hardware, storage, the networking, system management tools like Insight CMU, which is our cluster management utility. We work very closely with Adaptive to integrate our cluster management utility with the Moab scheduler. We did actually a demonstration at SC11 that showed cloud bursting using CMU for provisioning with Moab. So a lot of different things that we're doing. And then as we roll out cloud environments, we're taking, I would say in the public cloud space, we're certainly taking a very, very measured approach. We announced yesterday that we're moving from our private beta to a full public beta on May 10th. I think over time you'll see us introduce more high-performance computing friendly capabilities to the public cloud. But certainly today already, through what we call our cloud maps, which are really templates for deploying cloud applications, we already support things like Insight CMU. We have a cloud map for that, so you can use our cluster management utility in a cloud setting.
Excellent. So what, from your perspectives, what would, and I want each of you to answer this, what would you peg as the key inhibitors for cloud, both for HPC and for the enterprise? What's keeping people from moving faster to this?
I think for the enterprise, it's a combination of things. One is, risk. They really talk about risk. Where's my data? And there's some concern in terms of where the data resides, in the public cloud environment, and how controllable and accessible is it going to be. However, things are changing and moving faster. I think the next layer of impediment is the capability from a process perspective, from an IT operation perspective, is how can I manage my application that are going to be deployed on-premise, in a managed environment, or in a public environment. And how do I look at this application that's really, in essence, a composed application, because a new application, if you think about what's running on your iPhone today, on your iPad tomorrow, those applications are just not one footprint. They're all composed. They're talking to different services, or different software services, or even infrastructure services. And so how do I deploy those applications? How do I operate them? How do I know that they're working the way they're supposed to from a quality of service perspective? That is becoming a very complex job going forward. So the challenges and the ability to update cloud services over time is going to be, how can I take those applications, map them, model them, deploy them, operate them, and then retire them in a way that's still very efficient, and I can do that across all those different delivery models.
I think certainly one of the things that has slowed or held people back in adoption is just the wide array of cloud systems out there and their lack of interoperability, and not really being sure what the evolving standards are going to be, and not being able to play with traditional systems. If you look at, if you're running, for instance, an application on Google App Engine and you want to go move it to Amazon Web Services, you can't do that without rewriting a lot of code. So in the same way, if you're running Moab and you'd really like to keep running Moab and use that in a cloud environment, very difficult to do that today. And so one of the things that HP has done is really take an approach of adopting an open standards-based approach. So in our public cloud, we're basing that on a lot of key technologies around OpenStack, which is an open set of standards, and we're really we've made it partner friendly. So Adaptive wants to come in and enable Moab to run on the cloud, and we're working with you actually on that. That capability is there. So we really want to be open and really try to leverage the industry standards that are out there and innovate on top of those industry standards.
Excellent. So from an operation automation side, can that help bridge this gap?
Sure. So, I mean, like Mark just said, we want to keep the solutions and the approaches open so you can provide choice. We know that in the enterprise, you will have different solutions. You'll have different technologies. You'll have the existing, your cherish application that generate 90% of your revenue. And then you have all this new activity that's coming in, the disruptors and new technologies and new applications. And so I know the automation really needs to understand that. The automation has to be covering this heterogeneous environment. So it's all about choice. And we have to keep it open in the sense that, you want to have some level of standards so that as you bring the new technology, you can embed them, you can approach, you can make them part of your existing process. So it's not completely disruptive because at the end of the day, IT also has to transform and learn.
So I'd like to, I'm going to use my Godfather voice here, but I'd like to open up to the audience. Do you have some questions for our panel? Yes, please.
So your adoption of OpenStack or open standard means that you are viewing Ubuntu as ready for the enterprise for your customers, is that correct? And what is then your relationship with Red Hat and that OS?
I mean, one of the key premise of what we're doing is ability in essence. If you want to be able to operate a workload across, your private environment, your traditional environment, and a public environment, one of the key premises is to have a consistent access to compute. And one of the solutions out there being OpenStack, felt like it was appropriate for us to leverage. If you look at the work that's happening in the public cloud, that's one of the platform of choice. And so how do we bring that heterogeneity and this access to the compute infrastructure to this technology? So we're going to be behind that. We're going to be supporting it, working on it, and learning with the community as we go.
So speaking of community, one of the concepts that I've seen can be kind of interesting for particularly HPC is community cloud, where rather than trying to solve all the problems of public cloud, a group of like-minded organizations will put together a community cloud and share resources there. Have you seen interest in that, and any thoughts around that concept?
Absolutely. I mean, I'll start off. So we've been working in the academic space in the U.S. with the Internet 2 organization, and actually are partnered with Internet 2 and rolling out. They're in a beta stage right now with an Internet 2 cloud. Internet 2 being the network provider to 250 of the top universities in the U.S., being a bit of a unique opportunity to provision cloud services to those universities. But beyond that, we've certainly seen many specific, industry-specific service providers. Oil and gas is a great space where you have service providers today that provide seismic processing to a large number of oil and gas companies, and they're looking at how can they move from a sort of managed private cloud to more of a more public-like cloud for the oil and gas space.
Makes sense. Let's open it. Let's open it up to the audience again. Any more questions? Yes, please.
Well, for a user in the with an existing HPC environment, if this is not within the scope of the discussion, just let me know. But where would be a good starting point to get to a cloud?
So a great starting point would be to use Moab, right? Again, because of the work we're doing with Moab. I think, again, to look at, what are your applications where, you don't have massive parallelism and you don't have massive amounts of data. So we can easily segment out your application. Because, again, as we start rolling out HPC functionality on the HP cloud, right? We're not going to support a 1,000-node InfiniBand, Lustre file system infrastructure that runs massive MPI jobs day one. Right? But again, so I think you'll start seeing those smaller, more segmented jobs being the area where you can roll out. But again, ensuring that you're following industry standards, you're using well-defined types of interfaces in your code, and you're using scheduling systems from companies that are looking forward to how do they move into the cloud space. And again, we've already demonstrated prototypes of Moab doing cloud bursting. So I'd say, again, we're not quite ready to turn that on in the public cloud today, but certainly working on it.
Thank you, Mark, and thank you for the plug for Moab. As you can tell, my Godfather voice is working to produce the right answers from our guests. So it has been a useful tool so far. Thank you very much. Let's see if there's another question for the audience. Yes, please.
How are you going to differentiate against AWS, or isn't it necessary?
So I think, it's all about choice. And I think differentiating might not be a big word. I think you want to be able to leverage the resource pool you want for the application or the workload you want to work and deploy. And I think it's going to be a choice. As an IT owner and an IT department, I need to service my customer, my business partner. And the business partner is going to help me make those choices. I'm going to help them in terms of assessing risk, looking at what I need to do from a data placement perspective. And I will look at the solutions and the delivery model available for me. What I'm going to make sure is that I can help look at those applications, look at those workloads in a way that is consistent so that I can then deploy them in a dev test environment on premise or dev test environment, running in a public environment, and then transform that from dev test to production and quality workloads. How do I deploy this? How do I operate this over time? It's going to be really driven to the type of application and the nature of the work. And that's one of the benefits of a hybrid delivery model. Is you can go and choose the best available resources at a time of need. It could be a cost point of view, it could be a security risk, it could be an ease of use experience. And so you want that choice. You want this. We see it in the enterprise, and it's going outside of the wall of the enterprise. And so how do you bring those things together? So it's not going to be one, it's going to be many.
Another question? Yes.
So this is about storage. We are heavy on storage and data. So you brought up an interesting point about Lustre and Hadoop file system. So we have multiple petabytes of data. We still use the mountable concept, if you wish, the Polyserv, iBricks, GPFS concept. So Hadoop is a compilation of products, and one of the components is HDFS. Is that the future? Object storage. You don't mount stuff anymore. It all goes to an object-based environment. How do you see that going forward?
I would say it's driven by the nature of the application. I'm back to the soapbox around applications, but the type of application, the type of data they need to actually operate and shape. So an Hadoop workload and a Hadoop-like application will have the characteristic you described. A more traditional enterprise will have an RDBMS system, where it requires its own type of storage and its own type of capability. And as you move forward, where you'll move between what we call a structured environment to a non-structured environment, from a file system and storage perspective, how does that work? How are you going to be able to massively look at data across those things?
Yes.
So one of the key pillars, around some of the thought, with the HP announcement is you have your infrastructure, you have your application, and you have your data, your information.
So what if your data profile is unknown? In other words, it's almost random. So we're in the speech recognition business. Our data sizes and profiles are all over the place. So there is really no standard. When we build this file system for larger files, eventually we're going to get hosts because they use a lot of small files, and the other way around. So, we're kind of stuck in the middle where, the iBricks, Polyserv, GPFS prototype doesn't really work anymore because it's not really scalable. You can't mount petabytes of storage all the time. So, kind of trying to figure out, everybody's betting the farm on Hadoop. I'm not convinced that that's the real solution.
So, I'll take that. Certainly under our Exascale initiatives from the HPC group as well as from HP Labs, we're looking, well beyond the current capabilities of both Hadoop as well as products like Lustre. And I'm the biggest proponent of Lustre there is. As they say, I liked it so much I bought the company in a previous life. But again, I think that as you move to the second half of the decade, clearly need to move beyond sort of traditional file systems as we know them today and move to more of an object-based storage model because of exactly some of the things that you said. There's no file system today that can really scale to handle, millions of files and petabyte-sized files and the various streaming access rates that we know applications are going to need. So a lot of research going on in that area.
So is HP investing in looking at that type of storage, or you're more looking at others like Hadoop and follow their initiative? I mean, in the past, HP bought Polyserv and then Ibrix, and is there a trend, or is there just looking at?
So certainly under HP Labs, we have over 600 people in HP Labs. In fact, we're one of the few, the real sort of pure corporate research labs that exist. We're certainly looking at different types of data storage models beyond file systems as they exist today. I would say most of those tend to look at some sort of a key value pair, model and or an object-based model. So a lot of there is absolutely research going on in that area. I would say it's beyond things that would show up in products in the next 12 to 18 months, outside of that range.
Okay, thank you.
Next question. Okay, while we're waiting, and I'm sure you'll think of one, I'm going to ask another question. So, in terms of your system design and directions, and Mark, you just mentioned it with the Exascale initiative, but how do you see this aspect of cloud and HPC and the overall convergence story that you came up with yesterday? How is that affecting your systems and design efforts and direction?
Well, I think the biggest thing going on in systems design that's somewhat orthogonal to that is that for the last decade, basically, is the design model and the applications binary interface has been around a 2-socket x86 server running Linux or Windows, right? And we've already, I think, broken sort of free from that paradigm if you look at what's happening in the accelerator space and people programming in OpenGL or OpenACC on top of accelerators. And we see the start of things like ARM and other energy efficient processors. And what's driving all of that is in both the cloud space and in the HPC space, because of the massive workloads, there's such a focus on energy efficiency and performance per watt that people are looking at more specialized applications. And those specialized, hardware architectures need to be driven by a volume market. Right? No one can afford to develop a new architecture if they're going to sell 10,000 a year of them. Right? But in the cloud space and the HPC space, if you have an efficient model, you're going to go off and sell not 10,000 of them, but tens, hundreds of thousands of servers in that space. When you do that, as I said before, you're going to need to rethink how you design the server and better integrate the whole solution.
Great. Jerome, any thoughts?
Yeah, sure. From an automation perspective, is how can I best bring into the IT environment those services? How can I going to bring those resource pools into my infrastructure, or how I'm going to allow access to those services, in a public cloud environment? So this is where the ability to move an application, move a workload, for example, from on-premise managed to public is key. And an HPC workload would be an example of that, assuming you have access to a resource pool in a public cloud that actually satisfy the capability of the workload. Or you can run it on-premise. From an IT perspective, from an environment perspective, operational environment perspective, I need to be able to control that decision point. So I need automation that's going to allow me to make that decision. I need to expose those services in my automation that I can help a user or business partner to then select the right service, and then the automation should know where to go place the workload appropriately.
Great. Other questions from the audience? Yes, Michael.
How you doing? I wanted to know, does the HP have anything in place to handle ePHI data and comply with HIPAA so that way researchers can actually use the cloud for their research?
Not aware.
So I'm not the HIPAA compliance expert, but certainly in the healthcare space is a huge business for HP, and again, it's very much of a partner-focused effort. So Again, some of the large healthcare software providers like Cerner are huge HP partners and have been for many years. But again, specifics around HIPAA compliance products, I'd have to follow up with you on that.
Okay, thank you.
Michael?
Yeah, a separate question. This is having to do with virtualization in HPC. We're beginning to see more customers start. Some are doing experimentation. Others are actually starting to bring this into production for mobility purposes, for really trying to pick up that agility within HPC as well. What do you see this as well from an HP perspective, and are some of the barriers that used to be there being knocked down?
So absolutely, we see virtualization growing in the future in high-performance computing. It's inevitable because of the benefits. What's driving that is the work that's being done, at the network interface layer by the hardware vendors such as Mellanox. So we recently worked with a customer on a very large virtualized InfiniBand infrastructure with Mellanox and seeing actually excellent results with the latest Mellanox stack on top of that. So I think it's inevitable that they'll roll out more.
A related question, and it has more to do with the individual workstations and how that's changing in this HPC and scientific computing environment, but remote visualization. Are you seeing interest in that, and who and where are you seeing the most intense interest in moving to remote visualization?
Huge interest in that, right? And I think that the first wave of visualization, right, the 2D apps, the easier apps to visualize have already moved into that space. But if you think about it, as you get more and more data, right, having all that, moving bits of that data onto the workstation to virtualize it there, so people don't want to do that. You have security concerns, you have just the data movement concerns. It's much, much easier to keep all that data back in the data center and move it out. So we've been working, and the capabilities that are out there. If you look at some of the, advanced GPUs such as the M2070Q from NVIDIA that has both the server-based CUDA APIs enabled in it, as well as the display or Quadra APIs enabled. That sort of technology moving forward continues to drive the capability. So we see it as the software advances, you'll see more and more use of that.
Great. In fact, one of our partners that we resell is in this area, which is NICE, which is very heavily engaged in that area. One of the things I've seen is not only is there the security side, and I'm an old security guy, I totally agree with that, but also a desire and an issue with, can you really put enough power into the workstation to do as much work as sometimes is needed? And you end up overbuying workstations to handle, in terms of power, to handle the peak loads, and I've seen this in oil and gas especially. And most of the time, those workstations are heavily underutilized. Do you see remote visualization assisting with that kind of problem?
Absolutely, and the challenge is that in the oil and gas space, right, the experts in seismic, right, are all over the world, right? And if name your favorite oil company, they don't want to have to force all those experts to come in and sit in one building where the workstations are. And they can't today. Again, those workstations have to be closely coupled today to the data source. So today they can't just ship a workstation out to Cleveland, right, to where the seismic guy may sit and pass all that data. They really need to do it through remote viz versus shipping the workstation out.
And this is actually an opportunity when you look at the cloud and cloud services, where if you have technology like visualization that allows you to project out the workloads and the activities, you can now have specialized environment of cloud, potentially, that would specialize on those workloads and allow you access quickly.
It would seem like one of the inhibitors, thinking again of oil and gas, works great when you're in big cities. When you're in the field and the bandwidth is very poor, it seems like that's still one of our challenges. Any thoughts about, maybe bandwidth is one of the main inhibitors to this particular aspect? Are there others?
Well, it was interesting. I was meeting with a large oil and gas customer a couple weeks ago, and they said that the reason they're not using cloud today is because they had not yet found a cloud provider that would accept as input, a case full of tapes. And so, in the oil and gas space, that's still one of the 747 full of tapes is still the most efficient data movement. So maybe for the HP public cloud, we'll have to look at that usage model.
Latency is poor. Bandwidth is great. Other questions from the audience? Yes, please.
I just have a simple question because I've been hearing cloud so much that I really want to get a very good understanding of it. HPC to me, I'm not sure if it's ready for the cloud to the extent of the type of systems that we have. Will HP be looking at customers only who have HP systems in their environment, or will this be broader than just HP systems? And will it be able to handle, like you said, the infrastructures in most labs or most sites are UC systems where we have the InfiniBand and things like that. The problem I'm having with really feeling the cloud, it's okay for a scientist who has a desktop and he wants more resources, sure, but for a cluster of users, and I'm not sure enough about how Moab is interacting with that, if you can submit on your cluster and add to virtual hosts on the cloud to your environment to make your environment look the same as it is in the cloud. So how do we expect that to happen in the future, or how soon do we think that that may actually become the real driven path to HP computing in the cloud? I think that's one of our biggest concerns, why we haven't really jumped into it.
So from an openness perspective, if you look at the converged cloud messaging and the idea is that you want to bring heterogeneity to the environment. We know you're going to have a heterogeneous environment. You're going to have multiple type of resources available to you. And the nature of the applications you're going to have to deploy are going to call upon some of those different delivery mechanisms. As far as the experience is describing where, you want to be able to merge different types of delivery model with different types of workloads, I think it's really related to how you think about the application, how you think about deploying and operating that application. And so you might want to choose that for this type of application, you're going to use this HPC environment. But on the other hand, you're going to have potentially a workstation that's running into a public cloud environment potentially that needs to then connect and access that environment. Those architecture or those implementation of the applications are driven by your RT department, the team that's behind building that service. And they're going to want to have those choices and the ability. So from a thought process, the idea is keep it open, have the right bindings, the right API structure so that we can actually access the right, resource pools and then drive from there. It's not going to be just HPs. Open.
Mark, any additional thoughts?
I see the time signing back, so I'll pass.
All right. So we're going to wrap up. And I want just take 30 seconds. But if each of you in 30 seconds could, and I think it's perfect follow-on to that question, because there was an implied question when she started out and said, we haven't really looked much at cloud, or we're not really moving that direction yet. And I think you'll see that in many of our joint customers. What would your recommendations be for 2012 and into the early part of 2013? What would if you were recommending to HPC customers, what would your recommendations be for right now, what they should be doing relative to cloud? So, Jerome?
I think from a traditional enterprise or an IT environment, it's like, what can I bring into my environment that's going to be allowing me to learn and see what this cloud thing works. Your business partners are already doing that. They're already using their credit card and they're already going to some cloud services somewhere and experimenting with it. So the question is, what kind of workload I can bring into my environment and start learning from. So a dev test environment is a specific example where you can bring new application, new development activity is not going to be disruptive to your production environment, and you can learn from that. And then starting to map what does it look like when you have your new application that are trying to use existing and new, bring them together. So it's really about bringing something that's not going to be disruptive to what's running, and then learning from there and then building from there. Very similar to introducing virtualization in your data center. Very similar learning curve. We're just at the beginning of the cloud journey.
I'll just add, other than a few publicity stunts, you're not going to see a lot of multi-thousand core cloud HPC workloads or HPC workloads moving to the cloud. But start to learn, right? In the best place to start to learn and the easiest that you can do today is software development. Start looking at how you can move some of your software development onto the cloud for HPC.
Thank you. Thank you very much.